next week. Oh yeah, I have to do those tests, don't I?
Nice.
Okay. Next, we're doing logs. Logs. Yeah. So last time we were looking at powers. Now we're looking at logs, which is kind of like the opposite of powers. Okay, if you can write this down. Rules of logs. Have you got this, guys?
Yeah. I think I remember except one.
I don't know what you're saying. Okay. So firstly we have to say what a log is. So this part is called the base. And then this part here is called the argument. And the meaning of log is not so difficult. What you do to get the answer is you imagine what number do you put on the b to make it become the x. So for example, log 10 100 has to equal 2 because 10 squared is 100. What about this one? 3. Because 5 cubed is 125. What about this one? 1. Because 4 power 1 is 4. Music. Alright. You got that so far?
Yeah.
Yep. Now time to look at the rules we can have with logs. Scroll down. Yep. Okay. So the first rule. Log base b x x times y is equal to log base b x plus log base b y. This is the most important rule for logs. Most important rule. Does anyone know why this rule is so important? What looks so great about it?
You can split the logs.
Not quite that.
They can give you like unknown numbers.
No,
You can
no. You can do that all the time in maths. Why is this one is so important? Can anyone see why? The x is quite frequent in maths too. Yeah. The reason. Do you think you know? You sure? Okay. The reason this rule is so important in logs is because it can change a multiplication into an addition. So previously x was multiplying y, but now we have an addition in here. So this actually is very useful in algebra for helping to simplify certain problems which you'll have later. In fact, it's the whole reason logs were important to begin with. Okay, so this is a very important rule, the most important rule, rule 1 for logs. This is definitely worth remembering. The proof. So the way we prove it is we say let x equal b to some power and y equal b to some power as well. So then that means you have log base b, bn, bm. But using your rules of powers, that's log b n plus m. Yes? Now, b to what power makes b power n plus m? Well, it has to be n plus m. Because only b to the power of n plus m can make b to the power of n plus m. That's, I think, obvious, I hope. Maybe not so obvious 9 o'clock on Friday. You might want to watch this later. Never mind. Okay. I can change the n into this. Because b to what power b to what power makes x? Well, b to the power of n makes x. So this is n. And I can change this into log by. B to what power makes y? B to the power of m makes y. So this can be changed into log by. And that ends the proof then. It's good practice for your algebra to, I know you don't need the proof in the exam, but it's really good practice of your algebra to write down and understand this proof at least. So if you can write this down, please. Okay, do you have that one? The next one is so similar, I'll write it on the same screen. Rule 2. Log x divided by y, now you should write it again of course, is equal to log x minus log y. You probably could have guessed. And the proof is so similar, I just need to make small changes to it. Again, let x equal bn and y equal bm. Log bn over bm is log bbn minus here. This will be minus and this will be minus. So it's practically the same except divide and you have a minus, that's all, the only difference. Okay, so if we can write this down, this is rule 2. Got that? Yeah. Yeah.
From the before the last line to the last line. What did you do again?
Here to here?
Yep.
B to what power makes x?
N.
N. So n is the same as log bx.
Okay, yeah, okay.
Yeah. Can I do the next rule now? Rule 3? Yep. Okay, rule 3. Log b x n equals n log b x. And the proof? Log b x n equals log b x multiplied by x how many times? N times. By using the first rule, rule 1, you can change this into log bx plus log bx, etc. That's using the first rule. That changes multiplying into adding. And how many of these? Well, again, n of them, so it'll be n log bx. So that's rule 3. You can write that down, please. Come on. Still missing Nader. I was going to say who, but now I'm learning quickly who he is. Is he on immigration or something? Or?
Nope.
Ah, Nader. So now we're just missing Omar. Okay. Can I do the next rule? Do you have this? Yeah. Yeah. This xn is x multiplied by itself n times. Yeah. So that's log x log x log x. That's what rule 1 says, n times. Yeah. Yep. I can do the next rule now. Yep. Okay. Rule 4. Which one will I do now? I think I'll do the swappy one. Log. I should actually say, of course, different books will give a different number of rules and maybe write them slightly differently. So the only reason I'm writing the rules like this is because I think these rules are in the formula book. So I know sometimes students ask me, oh, don't you have this rule and this rule as well? So if you know more rules, that's fine. But I'm just covering the ones that you need for the exam. But there might be more that you know. That's fine. I'm just doing the exam ones anyways. So this one here lets you swap the x and the y, and the price you pay for swapping them is you flip it into a fraction like this. Okay. Okay. We'll try and do the proof for this one as well. So again, we'll say let x equal bn and y equals bn. So then log xy equals log bn bm. Now, I'm sure somebody will know this, but it's a bit hard. What does this equal? So b power n to what power will make b power m? That's it. M over n. Because the power you have to put here to make bn become bm is m over n. So it's m over n. Okay, so far? This is equal to 1 over n over m. The same thing. Which is 1 over an n. And then I can change this into log bm bn, because bm to the power of n over m makes bn. This is the same thing as this. What power do you need here? You need n over m. The reason I did that is so I can change it back to logs. This bm is y and bn is x then. Okay, so that proof is getting a little bit harder. This is rule 4. Don't worry about the proofs. It's just good to see them.
So the rules are going to be given to us.
Yeah, but I don't know. I have to double check the formula book. I don't know if every single rule is in the formula book. The formula book's on Moodle. You can have a look later. Okay, continue. Yep. Next rule. The next rule is when you want to change the base. So if you have base bx, but instead of base b, maybe you'd like to make it a different base, like base c. The price you pay for changing the base from b to c is that you must divide your answer by log c, base c, b. So if you want to switch from a b to something else like a c, this is the price you pay for doing that. Okay? Now, there's still one more rule next, but it's kind of an easy rule. I would like you to try to prove at least one of the rules. So, don't feel bad if you can't prove it, but I'd like to give you a minute or two to try and prove this rule. You've seen me prove 4 other rules, so you get an idea. I said try. You get an idea of what things you could do to try and prove it. Just see what happens. You're not going to hurt yourself. You'll be okay. See if you can prove it. Ugh. Oh, my eye! Ah.
Try, Zane, try.
I don't know.
Just type in a number and then
Okay. Anybody feel like they got the proof?
like put b x squared in the x.
Put what?
Put b squared in the x.
Squared?
Yes.
Why squared?
Or q or b.
Let's see what we can get. Okay. Can we look up, please? Yeah. Okay, let's see if I remember how to do this.
Oh, that's why.
Yeah.
Change log bx.
Give me a few seconds to process this.
Okay, you get it divided one?
No, I'm quite sick and tired. I required a pit stop in the middle of the proofs. Okay. First thing you have to do is to change the b and the x and the c into b to a power. Could be squared or cubed, but we'll just say n and m. Okay? So we'll try b equals, oh, I don't know, what's the worst that could happen? C power n and x equals c power m. Now, what I'm not sure in my head right now is should I use b or c? Well, it doesn't matter, because if I'm wrong, I just change my c's to b and that fixes it. So we'll just see what happens if we use it like this. So we have, and I don't see this working straight away. So I'll change it to c equals bn and x equals bm. Okay, let's see what I can get. Log bx is log b bm.
No.
What? Did I do something stupid?
Bn, like base Bn.
X is bm, isn't it?
Yeah.
So I just changed this into this.
Yes.
And then
That's right, isn't it?
Yes.
Okay.
then equals n.
No, but I'm just changing this into this. I'm not using this yet.
And this is M.
Don't freak me out, please.
M-E.
Please. Right.
M.
Interesting.
Just change b equals to x log or something.
Shh, I'm thinking. Interesting.
Put the numbers in, then we it'll make it so clear.
And not good.
Ian, I booked my multiple entry visa appointment
Mm.
on the 17th.
No, maybe I was right there.
Yeah.
I was right the first time. I should have trusted my feelings.
Confidence is the key.
I was wrong to do this. I should have used C as the base.
Yeah. They don't. This is the multiple entry. Yeah.
Like this. Always go with what your heart tells you. Alright. So let's see this now. Log bx. That's, oh yeah. That's cm and that's cn.
Yes.
Yes. And that's equal to n over m. Oh, now it's so obvious now. That's equal to log cx, and that's equal to log cm. Yeah, so I need b here. Oh yeah. Yeah, should have gone with my first instinct. All right, that's proof. That's rule 5. Wasn't that hard, actually? Okay, one more rule to do. It's not really a rule, it's more about what do you have when it's 1 and 0 and things like that. Can I scroll down? Yep. Okay, so first thing to say, rule 6. X, it's not really a rule, more like a use or a fact. X has to be positive. Cannot be 0, cannot be negative. It has to be positive. Okay, that's the first thing. Next, log b obviously is 1. And then log b1
0.
is 0, because only b power 0 can make 1. Yes, and the other thing we would like to say, b needs to be positive as well. Any other facts about it? X. No, these are the key ones. Okay. Now, I should also say that log.
With the calculator is
Huh?
about 10.
Say again?
The log and the calculator is base 10 always. So only
Not always, because the calculator we have, you can change the base.
But on default it's on 10.
Yes, but you can change the base. I should also tell you that log bx is a real number, meaning that although x can't be negative, the answer could be negative. The answer could be 0 or the answer could be positive. Okay. Please write these down and now we'll have a look at some examples.
The b is greater than 0 belongs to the upper part of the lower part.
However, everything.
So b has to be greater than 0.
Yeah.
Not equal to 1. So what about the log b1? Isn't it 0?
No, I'm saying the b here has to be greater than 0.
Greater.
But the answer could be 0. I never said, in fact here I'm saying the answer could be anything. You got this? Yeah? Yes? Can I do some examples now? And let me just open up the calculator as well.
What is the log b1 equals to 0?
Yeah, b to what power makes 0? B to what power will make a 0? Only power 1. Make sense? Yeah. Okay, can we do some examples now? Yeah. There we go.
Log b x c equals b
Okay,
b positive.
let's have a look at some examples as I enter my password.
Oh, what is IN? LN?
Yep, we'll get to that too in time.
Okay.
You know the A we did yesterday?
No, don't ruin the surprise.
Okay.
But then it can't be any number.
B has to be bigger than 0.
But to make it 0, you need the b to be 0.
Where?
Like in b to the power of 1 equals to 0.
Dude, you just asked me 2 minutes ago. I
Yeah.
explained it right here.
But then b has to be 0.
No, it doesn't, because what's 2 power 0?
2 power 1 is not 0.
No, 2 power 1 is not 0, you're right.
Yeah.
Yeah.
So what is power 1?
Are we talking about this rule?
Yeah.
B to what power makes 1? 0.
Okay.
So the answer is 0.
Oh, okay.
Yeah, that's what you wrote.
b power 1.
You wrote
Oh, sorry. Why am I
Friday morning.
Friday morning. And you just let me sit here like an idiot saying this.
You were complaining half a month.
We didn't want to ruin the surprise.
Thanks. Surprise! Oh, goodness sake. I can't even remember what I was saying here. Right, let me just take this one here. B to what power makes B?
1.
1. And take this one here. B to what power makes 1?
0.
0. Yes.
Now again.
That's what I meant to say. Thank you. At least I have one student I can count on. What? No? Alright, first example. You notice what I'm missing, don't you? What am I
Your
missing? My coffee. And this is what happens.
Okay.
Yeah.
You'll grow and you'll forget.
Yeah. Alright, first example. Let's try something like this. Now, in the exam, of course, you can type this in on the calculator, but that's not what they want to see. They want you to see, try to simplify, work it out. So I think the best thing to do would be to try and simplify the 512. So that would be 2, 256, 2, 128, and 128, 2, 4, 8, 16, 32, 64, 7, isn't it?
Yeah.
So it looks like this will be 2 power 9. I can use rule 3.
9.
This 9, isn't it?
Yeah.
Yeah. So this will be
9
9.
times 1.
Just 9.
Yeah.
Alright. Let me show you how you can check that on your calculator. There's a button here. Do you see it? Log. You can type in the base and the argument, and you get 9.
Oh.
Mind blown. Yeah.
What's the alpha log?
No, don't look. Way too early to be asking extra stuff, okay?
The bin?
Can I scroll down to the next example? Okay.
How did you get from the,
The 512, I just factorized it.
so we add the twos,
In other words, 512 is 29. Yeah. Okay. Can I continue? Next example. Log x 35 plus log x 5.
Log x 40. No,
No.
log 35 times 5.
Yeah, which is 350 over 2. 175?
175.
Yeah, that's what I just said. Yeah.
I also out of my mind, so.
I never said I was out of my mind, just tired.
I really, well, I'm like, I
You
was
can-
blinded.
Alright. How did I get 175? Was 35 times 5. So what rule was I using?
Second?
First. The most important rule.
Yeah.
Yes. Okay. Next now. We'll say something like 2 log 2 4. Ah, no, that's too easy. 6 log 125x minus 2 log 5 125. Okay.
Minus 4.
First thing, minus 4. No, we shouldn't have a number answer because there's an X in it.
First thing, use rule 5, I think, to change the base
Yeah.
of the second one.
So, if you look here, guys, the problem here is it's never good when the bases are different. We don't like this. We like to have the same base. There's an easy way to fix that. You could swap these and you make them the same base. So that would be log 6 log 125x minus 2 times 1 over log 125x. That's one way. Or another way, which I think is a little bit better, is we should try and simplify this 125 first. So I'll swap these. 6 times 1 over log x 125 minus 2 times log 5, and 125 is 5, 3. So this is 6 over log x 5 cubed minus 2 times, and this here is
1.
well, 3. So that's 6 over 3 log x5 minus 6. What's in common here? Well, actually, that can become 2. And I can swap this back now. I can get 2 log 5x minus 6. So this is the simplest I can make it. I'll sing it in class, please. Thanks.
How is the log E used?
That's coming up next. Don't be
Oh,
surprised.
no, I mean the like a math world.
Huh?
Like where do you use it?
Oh,
Pi is used for getting a.
E is used in calculus. It often comes up with things which are growing or decaying.
Oh.
So it's like a growth function.
Oh.
Okay. Next. Yesterday we saw this constant E. This constant E, when it's used as a base, we often just write it simply like this, ln x. This means natural log. So for example, what's ln e squared? 2. 2.
Oh.
E to what power makes e squared?
2.
Yeah.
So ln E is actually 1?
Yes. Yeah. Now, the other thing to say, this button is on your calculator. Please don't confuse it with this button on your calculator, as this one is base 10. And definitely don't confuse it with this button on the calculator, because this one lets you change the base. So, mistake students sometimes make in the exam is they mix these two up. Please don't. You can see them here on the calculator.
For rule 1, are we asked to reverse it?
Yeah, could be.
So how can we reverse it? Like log x 35 plus log x 5
Is log 35 times x, is that what you mean?
35 times 5.
35 times 5, yeah.
And how would we get it back to log x 35 and log x 5?
Which question is this?
This is the second example you gave.
I'll have to have a look at it in a second. Can you see here, look? This is the ln. If I type in ln 2, I get a different answer than if I type in log2. What should I get here? Guys, look up. What should this equal?
2.
2. And roughly should be roughly 1. Yeah.
2.718281824
Yep.
24 D.
This is E,
Kinda.
roughly. It's as much as I can remember right now. Right. And lastly, remember we have this button earlier where we can change the base. Yeah, so like, I don't know, 2, 2. What should I get here?
1.
1. And then, what's this one? 0. Yeah? Okay, the last thing to show you on this worksheet is the graphs of log. Can I scroll down? Yep. So, just like yesterday, we have 4 possibilities. A is positive, B is positive, A is negative, B is positive, A is positive, B is negative, A is negative, B is negative. Okay, first one. Graph looks like this. Yeah. What's this point here?
1.
No.
B.
No. No.
Not E?
No.
X.
What is it?
X.
No, give me. No.
Lan B. L B X.
Think. Wait. Think. Log of what makes 0?
Log.
Log of 1
Log 1.
makes 0. What value of x will make this 1?
0.
No.
1.
No.
X.
What value of x will make this 1? X. No.
0.
10.
Oh my goodness, give me it please.
Oh, exponent. No.
1 over b.
Oh.
I almost right.
What's b times 1 over b?
1.
And what's log 1?
0.
Okay. Alright, the next one. Now, I should also say here there's no graph on the negative. Okay? Right, next one. A is negative and B is positive, so it's kind of the same deal, except just upside down. Again, this is 1 over B. Here, A is positive, but B is negative. Graph looks like this. Again, this is 1 over B. Oh, goodness. And then the last one, I think, is like this. Oh, look, I made my circle. And then this one here, 1 over B.
Can you show us the graph of ln, please?
Just log x by itself?
No, I mean like ln.
By itself?
Yeah.
But this is log.
Oh,
So
I
log
see.
x by itself, where a and b are 1 and 1. Like, you mean like this, is it?
No, log E graph. Like the graph you showed us yesterday. I forgot to bring my iPad, so.
No.
Yeah.
You can copy that graph from someone.
Okay.
Yeah. What?
I wanted that one too.
Yeah. You know, if you took some notes in class,
I did, but not that one.
well, maybe if you write everything down like how teacher likes it, you wouldn't be in this situation.
Wanted to
Wouldn't you?
Maybe. I
Yes.
wanted to ask.
Yes.
If we're adding to the y function,
Yeah.
it will be plus c.
Yeah.
And if we're adding to the x function,
Mhm.
where will we,
That's a later lesson,
for the translation of those,
which is at this semester.
this semester?
Yep. Yep. Okay. Did you write that down? Yep. Okay. Let me give you some questions to do now. Can I scroll down?
If you want to.
I do. Oh. Okay. Homework. One, A, B, C, D. Two, A, B, C, D, E, F. They're very short. 3, A, B, C, D, E. 4, A, B, C. 5, A, B, C.
Can you just show us how to draw number 5E, please?
5E.
Yes, 5E.
What's the A? Positive or negative?
Negative.
And the B?
2.
So you're looking for a negative and a positive. So a negative and a positive. So it's this shape.
So the graph doesn't change when the E is in the base.
These ones, this is base E. But to answer your question, no, it doesn't really change too much. It still has the same curved shape to it. Okay, please write these down. I want to close this and then you can start them now. See what? Do you have this?